Let's take a look now at questions 25 and 26. Um, the key to understanding these two questions is to really read carefully the informational paragraph that goes along with this picture. So it says a crate on a horizontal frictionless surface. It's subjected to a force of magnitude F and exerted on the crate at an angle theta. So they show you F and theta. So it's pulled upwards like it has a little handle maybe on a wagon or something like that. The surface, sorry, so that the crate slides to the right. The surface exerts a normal force of magnitude Fn on the crate. So I'm showing that here in yellow, the surface kind of providing some support for the weight of the crate. As the crate slides a distance d, it gains an amount of kinetic energy delta k. So just defining that there's some distance it slides and it gains some kinetic energy because of this force. Now, F is kept the same, but the angle is now doubled, but it's still less than 90 degrees. So this angle theta is going to increase, and they're asking us to think about the implications of that. Okay, so the box, this crate is on the floor, the weight is directed downward, the normal force is the supporting force of the floor, and the pulling force is F, and I'm showing F now broken up into two components. A component to the right that we'll call F times the cosine of theta, and then a component, vertical component, which is going to relieve the floor of supporting all the weight. You can imagine if, for example, if this force was straight up, then the supportive force of the floor could be pretty small and could in fact become zero at the moment that the crate gets lifted off the ground. So this vertical component here, which would be F times the sine of theta, that vertical component will kind of share with Fn the supporting of the weight of the crate. Okay, so there are some vertical ideas here and there are some horizontal ideas here. Let's take a look at question 25, which is definitely a vertical interpretation of this problem. Okay, how does the new normal force on the crate compare to Fn? So Fn was our original supporting force, and if the angle is doubled, then this vertical component is going to be larger. So because there's more of an upward component to the force, the normal force, that is the force exerted by the surface, that can be lower. The weight of the object is not changing, right? So let's call it Fg. Fg would equal Fn plus whatever this supportive force is here, this upward force of F. So if that gets bigger, if that vertical force gets bigger, then Fn can get smaller. Okay, so the new normal force is less than Fn, which was the original normal force. Now let's think horizontally. As the crate slides a distance d, same distance they mentioned earlier, how does the new gain in kinetic energy compare to delta k, which was the original gain of kinetic energy? Okay, let's think of it this way. Work is equal to, so down here on the bottom of the screen here, work is equal to force times the distance, but those forces and those distances have to be in the same direction. So we can only consider the horizontal component of F, okay? At the same time, we know that work will result in the change in energy of an object, and in this particular case, because it's not going to gain any potential energy, it can only gain kinetic energy. So this product of F times D will be a direct link to how much kinetic energy changes for the crate. Okay, so if theta doubles, that means it's more. There's a greater vertical component, and it's going to mean that the horizontal component is less. So the new F cosine of theta will be smaller than the old F cosine of theta. The horizontal component will be smaller. The distance is the same, so the work done will be smaller, and then the change in kinetic energy will be smaller. So choice B here says that the new gain is less than delta K. All right. So just a quick recap. This problem has a couple of different parts to it, right? What's going on vertically and how much force does the floor need to supply based on how we're pulling on this, okay? And what's going on horizontally, which is a discussion of kind of the work energy theorem, right? That the work you do on an object can result in a change in energy. But the critical recognition is that the force and the distance have to be in the same direction. Okay, in a little bit, I should make available the next question, which is question number 27. Okay, so we'll take a look at that in a little bit.